Welcome to PGSMaths. In this video we're going to be looking quickly at pictographs and bargraphs. A pictograph, sometimes known as a pictogram, is a visual way to represent data. So if we look at this one, for example, this pictograph shows us the hours of TV that have been watched on different days. The key tells us what every picture means. So in this example, each television screen equals 1 hour of television. So on Monday, 1 hour was watched. On Tuesday, 2 hours was watched. Wednesday, nothing. Thursday, 1. And Friday, 3 hours. But what happens if the key was a little bit different? We change the key to mean a TV screen is 2 hours. In this situation, the TV for Monday represents that 2 hours of TV was watched. If we compare this to the data it's supposed to represent, Monday, 2 hours, that's pretty good. Tuesday is supposed to be 4 hours. So each TV, that's 2, 4, gives us the 4 hours. Now the table at the bottom here says that Wednesday should be 5 hours. And we have no TVs. So what we have to do is to draw in our own pictures. Well, if we want this to represent 5 hours, we have to draw our own televisions to represent that. It could be something very simple that looks close to my key. So one TV is 2 hours. If I draw another TV, that's another 2 hours, that's 4 hours. Drawing a full TV again would represent another 2 hours. So that would give me 6 hours, which is too much. We only want 1 hour, which is half of a TV, half of the value the key represents. So what we can do is only show half the picture. By showing half a picture, we have half the time, so that means that half a picture is 1 hour. Altogether, Wednesday now is 5 hours. Thursday, same thing. We're supposed to have 3 hours, but the TV screen only represents 2. So what do we have to add on? Well, we want 1 more hour, which is half of our picture. If you're designing your own pictogram, you make sure that the picture that you design is simple and easy to reproduce, and that the number that each picture represents should be bigger than 1, because the idea is it's saving us some time, but it's easy to split it up, so even numbers are a great choice for your key. Friday is supposed to represent 6, that's 2, 4, 6 hours. So what makes a pictogram useful? Well, it's a very quick and visual way of counting up lots of data and seeing instantly which piece of data has the most or biggest frequency. Looking at our pictogram here, we can see that Friday has the most TV watched. It has more TV pictures than anything else. If I wanted to compare Friday to Tuesday, we could see that there's 1 extra picture. So that tells us that 1 picture is 2 hours, means that there's 2 hours more TV watched on Friday. So questions like this are very typical. So what about a bar graph? What makes that different? And how do we make sure that we draw them accurately? For the same example, I'm going to show you how we build up a bar graph of this data. If there's a future video showing you a little bit more about what to do if the data that we're using is groups of numbers, I'll post that in the description below and place a link somewhere in this video. But for now, we're going to look at what's called discrete data. Data that's not related to each other, so therefore should be shown as separate values. Difference with a bar graph is that we have a frequency axis. Now this axis is either on the Y or the X, it doesn't matter which one you choose. That just depicts which direction the bars go. The frequency just tells us how many of each set of data there is. The important side is when you design your bar graph is to make sure that you have enough room for the maximum value of data, in this case 6, and that each number is on a line. 0 is always at the bottom, and then make sure that you're going up in the same amount of lines on your graph paper for each value of the frequency. If the numbers were too close together, like for example if the 4 and 5 were suddenly only 1 square away and then a 3 square jump up to 6, we're not going to get a very fair representation of the distribution. The idea of a bar graph is that every number is represented by the same distance. Now that we've got a frequency designed, it's a matter of putting this data onto the graph. Once again, try to make sure that you have enough space along your other axes to show the data, but bear in mind, as long as there's extra room on the page, you can always add a little bit more. There are a few important things to remember when drawing a bar graph. If the data is spread out and separated like we have here, then you should leave a gap between every bar. Each gap should be the same size, and each bar should be the same width. So for this example, I'm going to leave 1 square between every bar. I'm also going to draw every bar to be 1 square wide. This doesn't have to be the case. Your bars could be 2 squares wide, 3 squares wide. You choose, but keep it constant. So for Monday, I want to draw a bar that represents a frequency of 2. So I'm going to miss off the first square and start drawing my bar here. Using a ruler to make sure that the lines are straight, and we go up to the frequency 2. So starting on our axes, draw a line that goes up to the number 2. Now I mentioned I was going to keep my bars 1 square wide, so I draw it 1 square wide and back down to the bottom. That bar now represents Monday. To be sure of that, I could colour it in and give it a key. Could also label it. I'm going to leave the labels to the end to show you some of the typical problems that we have when labelling bars and how to avoid them. So let's just continue drawing the bars in the order that they're shown in the table. Tuesday needs to go to 4. Now I'm going to make sure that I leave the 1 square gap that I initially stated. So from here, draw another bar that goes up to 4. Make sure it's the same width as the first one, and then back down to the axes. I still have a 1 width bar, and I've left 1 gap between each square. Wednesday goes up to 5, miss 1 line, 1 wide, and back down. Thursday goes to 3, making sure that I am paying attention to the frequency scale that we designed, and not just counting 3 squares. Keep every bar the same width and have the same gap between all of them. This way we can make sure that when we're looking at it, we have a very, very fair representation of the data and can quite quickly compare each bar and its relationship. We can see a very big jump from Wednesday down to Thursday, showing a difference of 2 hours in this case. If this bar was spread over here to the far right, it might have actually created a very shallow slope, so it doesn't allow us to compare the data quickly. A bar graph like this is used very quickly to show if there is any patterns, any trends between the data, and to instantly see which ones are the most and least popular. Again, showing Monday with the smallest bar to be the least popular and Friday to be the biggest. Now I mentioned something about labelling the bars. It's very important that you know what each bar actually represents. So let's look at some of the common problems that we can see when trying to label bars in bar graphs. We know that the first bar represents Monday, but if I start to label this as Monday, you should see the instant problem. Which bar is Monday? Is it the first, second, third, or the fourth? The label goes all the way across all 4 bars. I could start writing Tuesday underneath, but once again there's no indication to which bar that would belong. So that's not a very good way of labeling our bars. We could try and write inside the bar, but at the moment my graph is far too small, so that would make things a little bit tricky. We can write sideways, that's okay, So if I put an abbreviation here, MON, I know then that that bar there is the only one with the title MON for Monday. Likewise, you would have to make sure that every bar was labelled in the same way. Without this label, we don't know what each bar represents, and therefore the graph is a little bit useless. In the same way, we also need to make sure that our graph has a title. In this case, we know that the data is showing hours of TV watched, with a title and label of our bars. This would be a fairly accurate bar graph. So here's our challenge of the day. It's a very easy one, this one. What is this? Is it a bar graph? Or is it a pictograph? Place your answers and any reasons for why you'd pick that in the comment section, or send them in to PGSMaths at Twitter, or even message me on Facebook or YouTube with your answers.